In 1997, something unnatural was heard beneath the Pacific Ocean. Not an explosion, not a machine, not an earthquake. A sound so powerful it traveled across thousands of kilometers of open ocean. It was detected by multiple underwater sensors at the same time, sensors designed for one purpose only: tracking nuclear submarines. Those sensors were never meant to listen for mystery. They were built to prevent war. The sound didn't arrive suddenly. It rose slowly, peaked, then faded away. The entire event lasted nearly a full minute. Scientists later named it the Bloop. What disturbed researchers wasn't just how the sound behaved, it was how loud it was. The Bloop was louder than any known marine animal, louder than most underwater earthquakes, louder than anything ever recorded in the ocean before or since. To understand why that mattered, scientists compared it to the loudest biological sound ever known: the blue whale. Blue whales are the largest animals to ever exist on Earth. Their calls can travel hundreds of kilometers through seawater. Yet even at their maximum volume, blue whale vocalizations didn't come close to the energy levels of the Bloop. For a living creature to produce a sound that powerful, it would need to be larger than a blue whale, much larger. That single calculation changed everything. The ocean covers more than 70% of the planet. Humans have explored less than 20% of it. Most of the deep sea remains completely unmapped, unseen, untouched. If something enormous existed there, it wouldn't violate physics. It would only violate assumptions. When scientists sped up the recording to make it audible to the human ear, the sound became even more unsettling. It wasn't chaotic. It wasn't violent. It was smooth, controlled, almost organic. It didn't sound accidental. It sounded intentional. And that realization raised a terrifying question. If something beneath the ocean made that sound, why did it only do it once? The system that recorded the Bloop was not built for discovery. It was built for fear. During the Cold War, the United States deployed a secret underwater listening network called SOSUS, the Sound Surveillance System. Its purpose was simple: detect Soviet submarines before they could launch nuclear missiles. Massive hydrophones were placed deep on the ocean floor, positioned in strategic locations across the Atlantic and Pacific. These sensors were incredibly sensitive. They could detect a single submarine propeller blade rotating thousands of kilometers away. They listened constantly, day and night, year after year. When the Cold War ended, portions of SOSUS were declassified. Scientists were granted limited access to the data. They began using it to study natural phenomena instead of military threats. Earthquakes, underwater volcanoes, the movement of ice. It was during one of these routine analyses that the Bloop appeared. On June 30, 1997, analysts noticed something unusual, a signal unlike anything in their archives. It didn't spike suddenly. It didn't crack or shatter. It slowly rose in frequency, reached a peak, then fell away. The waveform was smooth, clean, structured. That alone made it strange. Most underwater sounds are chaotic. Explosions are abrupt. Earthquakes are noisy and irregular. Ice cracking is sharp and unpredictable. The Bloop followed a pattern, a controlled rise and fall, almost like a call. When the signal was analyzed further, another disturbing detail emerged. It had been recorded by multiple hydrophones, thousands of kilometers apart. At the same time, that meant the sound wasn't local. It wasn't a small event. It was massive, powerful enough to travel across an entire ocean basin without losing coherence. When scientists calculated the energy required to produce it, the numbers didn't make sense. No known ship, no known weapon, no known animal. Nothing documented could generate a sound that's strong and maintain its structure. The source had to be extraordinary, and that meant it had to come from somewhere extraordinary. Using triangulation, researchers traced the origin of the sound. The location was remote, far from shipping lanes, far from human activity, deep in the southern Pacific Ocean, near Antarctica, one of the most isolated regions on Earth, cold, dark, and barely explored. Whatever made the sound did so in a place where no one was watching. No cameras, no witnesses, only listening machines designed for war. And once the sound faded, the ocean returned to silence, as if nothing had happened at all. After the location was identified, attention shifted to the sound itself. Researchers focused on its frequency. The Bloop operated at an extremely low frequency, far below the range of normal human hearing. Low-frequency sounds travel farther underwater. That's why whales use them. That's why submarines are designed to avoid them. And that's why SOSUS was tuned to detect them. But even among low-frequency signals, the Bloop was unusual. It wasn't chaotic. It didn't fracture or break apart as it traveled. It maintained coherence across enormous distances. That meant the source wasn't just powerful, it was efficient. When scientists sped up the audio to bring it into an audible range, the result was unsettling. The sound rose smoothly, peaked, then slowly descended. There were no sharp edges, no sudden bursts. It behaved more like a vocalization than a geological event. That observation sparked the first wave of speculation. Could it be biological? The idea wasn't as absurd as it sounded. The deep ocean is home to gigantism. Squid grow to enormous sizes. Jellyfish stretch longer than buses. Creatures in the abyss follow different rules. Pressure is extreme. Light is absent. Energy is scarce. To survive, life adapts. If a massive organism existed deep below, sound would be one of the few effective ways to communicate. Low-frequency sound could travel vast distances with minimal energy loss. In theory, an enormous creature could use it to locate others of its kind, or to mark territory, or to warn. The problem wasn't imagination. It was scale. The energy required to generate the bloop exceeded anything biological ever recorded. For comparison, even the most powerful blue whale calls are orders of magnitude weaker. For a living organism to produce the bloop, it would need not only immense size, but a physiology completely unlike anything we understand. That didn't make it impossible, but it made it deeply uncomfortable. As this theory gained attention, another question surfaced. If it was alive, why had it never been heard before? And why was it never heard again? The ocean is constantly monitored. SOSUS listened for decades, yet the bloop appeared once, then vanished. No repeats, no variations, just silence. That inconsistency troubled researchers. Biology tends to repeat patterns. Geology does too. The bloop did neither. It stood alone, an outlier, a single data point that refused to fit cleanly into any category. And in science, outliers are the most dangerous things of all. As speculation grew, scientists were under pressure to provide an explanation. An unexplained sound that powerful was not something they could ignore. Eventually, the National Oceanic and Atmospheric Administration stepped in. NOAA proposed a solution that was far less dramatic, but far more acceptable. The bloop, they said, was caused by an ice quake. An ice quake occurs when massive Antarctic ice sheets crack, fracture, and collapse into the ocean. These events can release enormous amounts of energy, enough to generate low-frequency sounds detectable across great distances. At first glance, the explanation made sense. The location of the bloop was near Antarctica. The frequency range matched what ice quakes can produce. The timing aligned with known periods of ice movement. On paper, the case looked closed. But when researchers examined the details, doubts began to surface. Ice quakes usually produce sharp, irregular sounds. Cracking, splintering, sudden bursts of noise. The bloop was different. It was smooth, gradual, controlled. It rose and fell like a single continuous signal, not a chaotic collapse. Another issue stood out. Ice quakes happen often. Antarctic ice is constantly shifting, breaking, and reforming. If ice quakes caused the bloop, similar sounds should have appeared again. They didn't. No other recording matched the bloop's acoustic signature. Not before. Not after. It remained unique. That uniqueness became the core problem. Natural processes repeat. Ice cracks repeatedly. Earthquakes recur. Volcanoes erupt again and again. The bloop happened once, and then nothing. As debate continued, another detail quietly fueled suspicion. Only a processed version of the bloop recording was released to the public. The raw data was never made available. Officially, this was due to the military origins of the SOSUS system. The sensors were still part of a defense network. Releasing full data could reveal classified listening capabilities. That explanation was reasonable, but secrecy invites speculation. Without raw data, independent scientists couldn't fully verify the findings. They couldn't analyze subtle details. They couldn't confirm whether important information had been filtered out. Some researchers argued that processing could alter the sound's character. That smoothing, compression, or filtering might hide crucial features. Others suggested the processing was necessary to remove noise. Either way, the lack of transparency created a gap, and gaps invite theories. Some suggested experimental technology, others pointed to unknown geological processes. A few returned to the biological hypothesis, not because it was likely, but because no alternative fully satisfied the evidence. The ocean, after all, has a long history of humbling assumptions. Hydrothermal vents were once thought impossible. Giant squid were once considered myths. Entire ecosystems have been discovered where science once believed life could not exist. The bloop fit into that uncomfortable pattern. Not proof, but possibility. What makes the bloop truly unsettling isn't any single theory. It's the silence that followed. For decades after 1997, the world's oceans continued to be monitored. Hydrophones listened. Satellites observed. Data flowed continuously. Yet nothing like the bloop ever appeared again. No echoes. No variations. No second chance to study it. If it was ice, it behaved unlike ice before or since. If it was geological, it left no trace. If it was biological, it vanished completely. Science relies on repetition, on patterns, on confirmation. The bloop offered none of that. It exists as a single moment, a sound recorded, analyzed, debated, and then locked in history. It reminds us that the ocean is not empty. It is vast, ancient, and largely unexplored. In 1997, something beneath the waves announced its presence once. Then it disappeared, and whatever caused it, the ocean chose not to speak again. The bloop also forced scientists to confront a deeper limitation. We don't truly understand how sound behaves in the deep ocean. Water temperature, pressure, and salinity bend sound waves in complex ways. Layers of cold and warm water can trap sound, channeling it across vast distances. This phenomenon, known as the SOFAR channel, allows low-frequency sounds to travel farther than expected. It's one reason SOSUS was so effective. But even accounting for these effects, the bloop still pushed the limits. Its coherence over distance was extreme. Its structure remained intact. It didn't scatter or degrade the way most natural sounds do. That suggested a source that wasn't just powerful, but precisely tuned to the ocean itself. Some researchers wondered if the sound had interacted with the ocean in a way not yet documented. Perhaps a rare combination of temperature gradients, ice movement, and seafloor topology had amplified it. A perfect storm of conditions, never repeated. That explanation was scientifically safer than monsters, but it came with a cost. It meant admitting that Earth can still produce phenomena we cannot reliably model or predict. And that's unsettling in its own way. As years passed, the bloop became less about what caused it, and more about what it represented. A reminder of how little we truly know. The deep ocean remains one of the least explored environments on the planet. Humans have sent probes to distant planets, but only a handful of crewed missions have ever reached the deepest parts of our own seas. Most of the ocean floor has never been seen directly. When new data does emerge, it often rewrites assumptions. Entire mountain ranges have been discovered underwater. Rivers flow beneath the sea. Lakes exist in complete darkness, sealed off from the rest of the ocean. Life adapts in ways that defy expectation. The bloop fits into that pattern of discovery by accident. It wasn't found because scientists were looking for it. It appeared because a military system happened to be listening. That raises an uncomfortable thought. How many other anomalies have occurred where no sensors were present? How many sounds were never recorded? How many events passed unnoticed simply because no one was listening? The bloop may not be unique. It may only be the one we caught. In the end, the bloop resists a satisfying conclusion. The official explanation points to ice. The data supports that interpretation more than any alternative. But science is not certainty. It is probability. And probabilities change as knowledge grows. What remains undeniable is this. On a single day in 1997, the loudest underwater sound ever recorded crossed an entire ocean. It came from a place humans rarely reach, was detected by machines built for war, and has never been heard again. No repeat, no confirmation, only a record. The ocean has always guarded its secrets. Shipwrecks vanish. Creatures surface briefly, then disappear for decades. Signals emerge, then fall silent. The bloop is one of those moments. A reminder that beneath the surface of a mapped world, there are still events that escape explanation. Not because they are impossible, but because we haven't listened long enough. There's another reason the bloop refuses to fade away. It was not discovered in isolation. It sits within a long history of unexplained ocean sounds that scientists still struggle to categorize. Throughout the late 20th century, SOSUS and similar systems recorded other anomalies. Upsweeps, whistles, low-frequency rumbles with no clear source. Most were eventually linked to ice movement or seismic activity, but some remain unidentified. The difference is scale. None matched the bloop's sheer power. None traveled as far. None maintained such a clean structure over such distance. That combination makes it stand apart, almost like an outlier among outliers. In data analysis, outliers are often dismissed. They're inconvenient. They complicate models. But sometimes outliers point to something new, a missing variable, an undiscovered mechanism, or a gap in understanding so large that existing explanations can't fill it. The bloop may be one of those signals, not proof of something extraordinary, but a marker, a flag planted at the edge of what we currently understand. There is also a psychological layer to the bloop's impact. Humans are uncomfortable with the ocean. We depend on it, but we fear it. Its depth, its darkness, its scale. We can see storms coming. We can watch volcanoes erupt. But the ocean hides its events beneath kilometers of water. When something happens there, we often only learn about it indirectly. Through sound, through vibration, through instruments designed for other purposes. The bloop triggered a primal reaction because it reminded people of that vulnerability. Something immense occurred beneath the surface. It announced itself once, then withdrew. Whether it was ice collapsing, a rare geophysical event, or something we don't yet recognize, the effect was the same. It exposed how little control we truly have over the planet we inhabit. The ocean does not owe us explanations. It does not repeat events on command. It does not reveal its processes simply because we are curious. Sometimes it offers a glimpse, and sometimes that glimpse is all we get. In 1997, the ocean spoke, not loudly in human terms but powerfully in its own, and then it returned to silence, leaving behind a question that still lingers. What else is happening beneath the surface that we haven't heard yet?